Object. And another cool thing I want to show you is this is also the way you can make these objects a little bigger and give them additional colliders. For example, I can duplicate the sphere and now I can drag this sphere into this sphere. Now all I need to do is remove the rigid body from this sphere, from sphere 1, from the child. So the objects inside these objects are called children, and obviously this here is called the parent. So only the parent needs the rigid body. But in here we can add a lot of cool stuff. We could even add another cube if we wanted. Let's do that. Nice. Now we have a weird worm-shaped thingy. Let's rename that to worm. And now we can duplicate that as well if we want. Maybe make a new folder here by creating an empty object, making sure this is directly in the hierarchy, and dragging all of our worms in there. Worms. Let's see how this looks in action. Hell yeah. Another pro tip, by the way, if you want this to be maximized whenever you hit the play button, just click maximize on play here in the games tab, and now when I click play, this will be a little bigger. Now if you think this is still not clean enough, you could even create another object, call it something like physics objects, and put your objects in there. So this is how you create these parent-child hierarchies that make handling and dealing with a huge amount of objects a lot easier. Now let's say you want to give your objects a different color. The way you do that is by right-clicking into the projects folder, create, and then material. I'm gonna call this one material 1. Now in the inspector you can see the material properties. The only thing we want to change right now is the albedo color. This is my reference. Just gonna pick this color. You can duplicate these with Ctrl D as well. I want to have 5 of them, so I can just copy those colors here. Here we go. Now I selected some nice colors. Let's put all of these materials into a folder to just keep it clean. Let's call the folder materials. Select all of these, drag them in there. Now you can basically just drag these materials on these objects. Or if you don't do that one by one, you can also just select all of them. For example, I can select all of the cubes. And then here in the mesh renderer, if you open materials, this slot right here, element 0, is where you drag in the material. And with that you can color all of these at once. Then we can give the ground a different color once again. Now let's select all of these objects in the worms. Make all of these yellow. Et voila, we have some colored objects. Hell yeah. You can see that there's already a folder in here. It's called scenes. And this is probably the scene you're in right now. If you double click that, you get asked if you want to save the current scene, because this scene will be loaded. So yes, we want to save that scene. But actually this scene is exactly the same. So nothing changes when you double click it. If we create a new scene, here we go. You can rename it. So this could, for example, be a different level or a different part of the game. If you double tap that, we're in a completely different scene. All of the objects from the other scene are gone. We only have our camera and our light, but obviously you can go back to the old scene anytime. Here we go. Maybe we want to create an object in scene number 2. Voila. Now we obviously need to save that scene. For that we go to File, Save Scene. Also make sure to hit Save Project every once in a while. Best practice is probably just doing both, Save Scene and Save Project. Save Scene really just saves the objects in the current scene. Save Projects basically saves some project settings and objects that are here in the project folder. Save Scene probably even a little more important though. Okay, let's get rid of all of this crap right here. Let's just keep the ground plane, make that even again by entering 0, 0, 0 into the rotation. Then I'm gonna create a new sphere, give that a rigid body. And now let's write our very first script, and let's make a new folder for scripts. Don't worry about the prefabs folder, by the way, you didn't miss anything. I decided to cross that from the video because prefabs are going to get a pretty big overhaul sometime soon, and we do not need them for the rest of the video. Then you right click into that folder, click create, and then you click C# script. Let's call it add constant velocity. Now if you double click that, a text editor will open. For you it's probably gonna be mono developed. For me it's a Visual Studio. Doesn't make a huge difference for now, and this is what you should see. First thing you should check is that this string right here, this name right here, needs to be the same as this one, as the name of your file. Otherwise you're gonna run into problems, so always check whether this string is the same as this one right here. Most of the stuff you see here is stuff we can ignore. The only two important portions are this one and this one. This is for initialization. All of the code we write in here will be executed once at the beginning. Everything we write in here, update is called once per frame, will be called once per frame. So that's about 60 times per second, 100 times per second, depending on how fast the game renders. So this is not a fixed time interval, depends on how good your graphics card is, but this will be executed constantly. So far we didn't write anything in here. Anyway, we can still attach the script to objects just like these components right here. So you can find your own script, add constant velocity z. I could add that right here. If we click that small gear wheel, we can click remove component, then it's gone again. And another way to add it to your object is just to drag it on here. Here we go. So all of the things that are already on our sphere object right here are basically scripts that we didn't have to write ourselves, right? This one is one we're gonna write ourselves. In order to make our object move, we need to communicate with this script right here, with a rigid body. That's the script that handles all of the physics simulations. So we need to contact that script. The way we do that is we write get component. Then we make this weird bracket right here and write rigid body. Then you open and close a bracket. Don't worry about all of that too much yet. You'll get used to the syntax as you go. All you need to know for now is this returns the rigid body of this object. And now if we write dot, we can see all of the things we can do with that rigid body, all of the variables, all of the functions this object has. The one we are looking for is just the velocity, and the velocity is a vector, so the direction and the speed the rigid body is moving in. In case you're wondering how a vector looks like, a vector basically looks like that. It has an X component, a Y component, and a Z component. So this basically just sets the horizontal speed to 2, the vertical speed to 10, and then the speed in the Z axis to -6. So the Z axis is this blue one right here. The way that looks when we launch the game is nothing, because we need to save the script first. Now it's recompiling. Now if we click play, our ball flies away into this specified direction. So let's just try to make it move only into the X direction, okay? So we're gonna set Y and Z to 0. Now it should only move on the X axis in theory. Let's see if that works. Yes, it does, but it's also not falling down anymore. And there is a very logical reason for that. It's because we're setting the velocity exactly to this vector. That means whenever our object starts falling down, this Y velocity usually gets a lot higher, but we also reset it to 0, so it can't start falling down. What we can do about this is just changing this equal sign here to a plus equals. So whenever you write an equal sign in coding, that means we set this variable to this value. So the velocity of this rigid body will be overwritten with this vector. If we write a plus equal sign, that means we will add this value to this, meaning the X velocity will get 2 higher every single frame. That will obviously be a little too fast, so let's lower that to 0.1, and then we need to write an F to indicate that this is a float value. So whenever you have numbers like that contain a dot, probably need to write an F after that. There are different kinds of variable types, different kinds of numbers, and we just want to tell the program that this is a normal float number, so that's why we need to write the F. Okay, now it's falling down again. Very nice. Now putting that into the update function is a little risky, because we do not know how often the update function is called. So if our game is running faster the ball also speeds up faster, because every time a frame is rendered, we add something to the speed. That is obviously a problem. So your game will basically run faster on faster machines. That's not what we want at all. So what we'll do for now is, instead of coding everything into the update function here, is coding everything into the fixed update function. And fixed update is called exactly 100 times per second. We can rely on the fact that this will always run with the same speed. It's always good to code physics stuff into the fixed update function. Now what we want to do is creating a little settings window right here where we can specify the speed of this object. We want to be able to change this right in the editor. We don't want to go into the script every time we want to change the speed of this. So let's just write vector3. So this tells the program which kind of variable we want to have. And now let's name our vector. You can name that whatever the hell you want, but usually it's a good idea to have a little indicator at the beginning of the variable which kind of variable this is, so you can see that more easily later on. I'm gonna call this v3 force, then just make a semicolon. Never forget to make the semicolon at the end of the line. I forgot to mention that earlier. Here needs to be a semicolon, of course. If we want that to be modifiable from the editor, we need to make these brackets right here and write serialize field. This serialize field attribute will apply to this variable. Now if we go into the editor, we can see our variable appears right here, and we can modify the variable right here in the editor. Now all we need to do is replace this vector down here with our new custom vector that we can modify from the editor. We don't need the start event, so we can delete that, clean this up a bit. Here we go. So this is our very first script. All it does, it just applies a constant force to your object, and you can change that force right here in the editor. So let's make a couple of experiments if this works. Let's, for example, set the force to 0.1. Here we go. Goes to the right. Now let's set it to minus 0.05. Now it should go to the left. Perfect. Enter 0.2. Yes, it's able to overcome gravity. Now it's going upwards, and all of that obviously also works in the z-axis. Perfect. Our first script is hereby done. Next thing I want to do is make the sphere controlled by the player. For that we're gonna need a new script. Let's just duplicate the one we already have. Let's rename that to add player controlled velocity. Then I'm gonna copy that name and double click that, so now it's open here, and then remember to replace this with add player controlled velocity, so it has the same name as the file. And now I just want to add two more serialized variables, two more of these serialized fields. This time the variable type is key code, so a button. Let's call this one key positive. Let's duplicate that and call this one negative. Now if you save that script, let's remove that component and add this component, add player controlled velocity. We should have a force vector right here, and then we should be able to choose a positive key and a negative key. And now the way I imagine this will work is I can say I want this object to move on the x-axis, so I'm gonna put a 1 here. Then we could, for example, choose let's choose right arrow for positive and then go with left arrow. Obviously this doesn't do anything yet. What I want to do now is just add a new if statement. If statement looks like this. You write if, then you open a bracket and you close a bracket, input dot get key. Then we open another bracket and close another bracket, and in those brackets we write our variable key positive. Then go one line down here, press tab. Here we go. So now this force is only added if we press the positive button. Let's do the same with the negative button. Only difference, when we press the negative button, we don't want to add the force, we want to subtract the force. This way we can move in both directions. Very simple script. Should work out just fine. Let's give it a go. Alright, it's a little fast, but I can now control the ball to the left and to the right. Let's make it a little slower, 0.2. That feels nice. Obviously you can also use a different axis, the z-axis for example. Now we move diagonally. If we move the x component of this vector, we're just gonna move vertically